Great, thank you very much. All right, well, thanks for the introduction. As Annie said, I lead the work we do at CCS Insight on IoT generally, and I focus mostly on industrial IoT. I'm also Chief Operating Officer for the company. Now, my starting point for this talk is a little bit different from others. So the starting point I'm taking is that most industrial and enterprise IoT does not use cellular for its connectivity. And what I want to do, starting from there, is focus on two major trends that we see coming through in our research and see where they lead and draw conclusions for the telecoms players, especially as we move towards 5G, when the connectivity becomes much richer and much more interesting in what it can offer into IoT systems. And the main conclusion is in the title here, which is that there are some very strong parallels between where enterprise IoT is today and where the smartphone market was in 2008, when Steve Jobs launched the App Store. And so bear with me, I want to have a look through that. Just to start with a very quick intro into CCS Insight. We're a medium-sized analyst firm based in London and Silicon Valley. We do research work and advisory work across enterprise and consumer technology landscape. And we mostly serve suppliers in the industry, and we've listed a few on this slide here. We're quite happy with the quality of our client base, and of course, we're looking to expand from here. So let's take a look at enterprise IoT then. And Fernando has already mentioned this, but until very recently, we always used to sell enterprise IoT like this. It was a complicated series of components from many, many different suppliers around the world, and the system responsibility fell basically on the user. And many users use systems integrators to help them with that, but it was very clear where the responsibility fell, because mostly what we were selling was components. Recently, though, we've seen some companies taking a different approach, and that comes about because we now understand many of the use cases much, much better. And so this is our first trend. We're very pleased to see that the selling has shifted so that we're now selling finished systems which have been pre-specified, pre-tested. Systems integration is largely done so that the system itself is scalable, and all that the customer needs to do is make sure that it links nicely with their existing business systems, because they can take more of the system they just bought for granted. Now, this approach has been pioneered by Intel and Dell, and others have picked up the baton, including Cisco, Libelium, and others who are big in IoT. And it sounds so obvious, almost stupid, but actually this approach works better. We're seeing much faster growth. There are not enough people who report their IoT numbers, but Intel's IoT group before the COVID outbreak was running between sort of 12 and 20% per annum growth quarter on quarter. This is a much healthier growth rate that we're seeing. One of the things, and Fernando just mentioned this, is that in telecoms, we often still see the component mentality, and we think, we need to move on from that. And this is one of the key trends. The second key trend is that we now understand the architecture needed for enterprise IoT much better than we ever did before. We understand that there's cloud computing and storage with various functions there, that there's edge computing and storage component, whether that's edge in the carrier's network or edge on premises, both are possible. And there's a sensor layer. Now, each of those layers has its own software stack. There are certain functions that run in each layer and are needed across the system. And we know that we can add apps and functions over time so that the system grows and evolves and the functionality changes. And what that means is that we've settled on a decentralized and software-defined architecture. This is the basic architecture that we have. And a really good way to illustrate this is that if you think about autonomous cars compared to a sort of office type environment, autonomous cars are a brilliant example of all of the challenges and all of the difficult things to get right in building an industrial or an enterprise IoT system. And I think you can see that whether we're talking about autonomous cars driving around the roads, or whether we're talking about an array of industrial gateways spread across multiple factories, actually, philosophically, they're almost identical. The only difference with the gateways is that they don't move very much or very often. Now, what's really, really important as we think about this is that each node in this distributed system is a general purpose computer. It's configured to do specific tasks by having an operating system and some apps running on it. So each node has a full software stack ranging from the firmware, the operating system, the apps, some machine learning, some security, and it probably also has a data layer in it too. And what that means is that there's a certain array of plumbing tasks. I call it plumbing, and you'll see why as we go through. These are tasks that basically keep this distributed network of nodes up to date, secure, and running, doing the job that we want. And to do that, what we need to do is make sure that all of the software in the stack is curated, is vetted to make sure that it is what it says it is, that it's downloaded to the correct devices at the correct time, that it's secured, it's patched, and it's updated on a constant basis. And that needs to be done for every single node in the system. Now, doing those tasks securely and at scale is really hard. And what I think is interesting is that it is exactly the set of tasks that we do for millions and millions and millions of smartphones around the world, and PCs and other types of computing. And what we find from this is that the economics, the technology issues, and the community of developers that goes with this have meant that this, in smartphone terms, is a highly concentrated area with really only 2 companies serving the bulk of the Western world's markets. That's the Apple App Store and, of course, Google Play. Now, our view is that industrial IoT has become a similar sort of system with millions of general purpose computers on distributed architected networks, and that we need app stores and software update services as plumbing to keep all of this doing what we want in a secure way and up to date as possible. Now, very, very few companies are really good at doing this at any scale. We think that this is where the smartphone analogy isn't perfect, so Apple may not be the answer for industrial IoT, at least not for the moment. But when we look at some of the companies who are starting to do this already, here are some that we found who are already taking this position in industrial IoT. And you could add a few to this, so PTC, for example, you could add. What I think is really important about this, though, is that there are more than 500 IoT platforms in the market around the world. And weirdly, we keep finding more, and we keep bumping into companies who are writing a new IoT platform. And the answer is always, well, why? Why are you doing that? What I find interesting is that most of those 500 will not be good enough to do the plumbing tasks that we need at the right scale. So we are expecting enormous consolidation among IoT platforms going on from here. So let me just then sort of round up these trends, see what that means for industrial IoT, and then reflect on what that means for the cellular world, or the mobile connected world. Well, the first thing is a few conclusions about IoT. So we know that customers want finished systems to serve key use cases, and we know they want those to be extensible so that once they've bought one, they can then add new use cases to it. We also know the architecture that's needed and we know that managing that architecture is quite a complex task. And so our first conclusion is that the DIY over, or at least they should be. There are still people doing. We think that what you need in an industrial IoT system is professional plumbing, and it makes no sense at all to build a new system yourself. The economics are all against you. More than that, the software throughout the stack in your system under these conditions will be managed by a few large specialists. Now, basically, this is fantastic news. If you're a machine supplier and you want to enter the IoT age with your machine, you can now do it just by becoming an app developer. You don't have to develop the whole system. You can develop your app and then join in with somebody else's architecture. That's a much easier and cheaper task. And you get better infrastructure because you're relying on somebody else's system and the maintenance that they are putting in to do it. So basically, that's really, really good news all around, just like it was for smartphones and continues to be. It does have a few implications, though, which is that not many companies are really good at doing this stuff. And the few large specialists who are good at doing it are likely to become very powerful and will become the hub of large ecosystems. And then, of course, as suppliers in the industry, we face choices about, well, which ecosystems do we join, which do we support, which do we not join? Okay, so our thesis is that we are having this iPhone moment in the market. As far as we can tell, this is starting now. There are some companies taking that position. There are people buying those sorts of architectures, but it isn't fully played out yet. We think that's going to take several years. And so using the smartphone analogy, we are in about 2008. You know, the world in about 2015 equivalent is going to look rather different. There's a lot more evolution to come in this. But what does all this mean then for telecoms? Well, as far as we can see, the focus on finished systems means that most of the value is in the solution, not in the plumbing that helps the solution work properly. And I think Fernando mentioned this aspect too. Now, connectivity from the telcos is an important part of the plumbing, but it isn't the solution. Okay. What I find interesting is that connectivity will increasingly need to form part of someone else's system architecture. And that's especially as we move towards slicing and APIs as the normal mode of interaction when we get towards 5G networks. Now, the good news here is that if you start selling packaged solutions, that really helps build value beyond connectivity. As we understand it, the connectivity is something like 5% of a system's value. So it's really good if you can also focus on the 95% as well. Operators may provide the connectivity for some of those packaged solutions, and in doing that, they will increasingly need to join multiple software ecosystems from some of the providers I've already mentioned. More good news is that if you do package solutions like that, that doesn't mean that it's a closed, fixed point solution. That's the purpose of the good software architecture. And if you join in with a good software architecture, it's extensible. And so having sold that first system, you then have options about adding new use cases onto the same infrastructure and building it out. And we know a number of IoT suppliers in the market who quite deliberately have a land and expand strategy where they get the first system in and then they work around the account to build out the use cases quite deliberately. So there are good opportunities having done that. What I think this means then as we move towards 5G is that 5G needs to be a full paid up member of this architecture, and it will only become material in enterprise once it's easy to use 5G and the APIs and the slices as part of somebody else's software architecture. And once network slicing is real and you can deploy network slices across countries as easily as you would deploy say, an AWS instance, for example. And once the security is fully defined, and by that I mean not just the security of the connectivity, but how a slice should work when it's connected to your corporate network. What's the security protocol across there? People need to know that, understand it, and trust it before we can start to see a significant quantity of 5G joining in with the IoT architecture. But it's also important to recognize that these are starting conditions. Once we have these, then we can start to build scale in the market. Before that, what we'll see is lots of pilots and trials, and there are a lot going on, we know that, but we will not see any scale because people won't be comfortable or happy adopting it as an integral part of what they're putting in IoT systems. So thank you very much. That's the formal presentation from me. It looks like we may have made up a few minutes, but we have a time for some questions, if there are any.
Thank you. That was really interesting. So I have some, and maybe other people get the courage up. So you were talking about, you feel that we're just at the beginning of these changes now, like the equivalent of 2008 with the iPhone stroke App Store. I was just wondering if you think that the pandemic is going to accelerate this process.
Yeah, thank you. That's a really interesting question. So our view on the impact of the pandemic, and we've already seen some people reporting their results, is that there will be an initial hit, but that IoT could be a really important part of the recovery from COVID. I do think, though, that IoT tends to fit into companies' operations, and those are going to be sort of limited by GDP. So if there's a big recession, then people's operations will be smaller. And so I think we shouldn't expect just a boom in IoT, but what we should expect is that there are some really important use cases that we can start to address using IoT, and that, you know, there are some good opportunities come out of that. And by that I mean, you know, things like as you walk around an office, do you have to touch light switches to switch the lights on? Could you use an app on your smartphone as an office user instead? And the answer is yes, you can. It needs a bit of investment to do that, but there are some really good systems there that help protect against COVID.
Slightly a tangent, but I was interested to note that Telefonica has just literally yesterday announced some solutions to help open up public spaces safely. So the idea is it's going to use the data it has from people's phones to sell services that both monitor safety and hygiene regulations are complied with to try and protect everybody's health, but also to better understand how people's behavior has changed. And I think this is from branches of banks to you know, shopping malls to public spaces, public services. So I thought, and that's quite interesting, and talking about IoT as a way of reactivating public spaces. And I thought they were jolly quick off the mark. So, you know, good for them, really.
Yeah, I would absolutely agree. And one of the nice things you can do as a mobile operator is that you can do anonymous views of how the population moves around spaces. And so you can study these things and do it in a way which is privacy protected, unlike sort of surveillance cameras and things. And so, yes, I think the mobile operators have a really interesting role in some of those things. And, you know, well done Telefonica, as you say, for being so quick to do that.
Yeah, I just thought it was quick. I'm having trouble with my Q&A panel. I'm just not having a great day of it, am I, with technology? So someone has kindly asked, in Huawei's role, how do you see Nokia's Wing as a way forward as a technical option, I think is what it says.
I think Nokia's Wing is a very interesting example of one way to behave going forward. So, and it's this business that, you know, if you imagine autonomous vehicles and they suddenly want to light up a new service, or a new feature across their vehicle fleet, they want to do that internationally and all at once, then a separate core network that allows you to do that is an interesting way to do it. It doesn't have to depend on individual national carriers and the commercial agreements between them. I think we're going to see a number of more novel approaches and sort of business setups to do this as we go forward on this.
Okay, there is another question. Martin, can you look in the Q&A box, the fourth question, because I can't read it. For some reason, my Q&A has evaporated.
So it says, you mentioned that the telcos can expand their provisions from just connectivity to end devices for B2B. I think this could be a good market, but on the other hand, to individuals, do you think they would be willing to pay more for what IoT is willing to offer? I mean, the market value now for the mobile operators. Well, I would say that we have seen from the mobile operators some good packaging of solutions around very specific use cases. And the question here is about whether that also plays into the consumer space. I think there's quite a lot of example. If you start looking at smart home and some of the amounts of money that people have been investing in that there is a willingness to pay. I worry a bit about COVID and the disposable income, whether smart home will become a bit discretionary, and that we may see that slow down quite a lot. But I think, if you get the product right, then there is a willingness to pay for that. And we shouldn't just assume that something coming from an operator is automatically more expensive and therefore people wouldn't buy it.
Okay, so actually that's quite interesting, Martin, because that rather echoes the view of Kai, who spoke to us in the first part of this conference, very particularly about the smart home and the considerable research that they've carried out into it. So that's interesting that seems to concur. Yes, it's always good when that happens, isn't it? Thank you. I found that a really interesting session, and I think it'll be very interesting to see how it pans out, and actually particularly how quickly it pans out. And I'm also curious to see how the issue of interoperability, when we have a few big stacks, is going to work as well, and how much that will matter in the long run.
Just on the speed, if I may just put in one answer there. We do find that the industrial world runs on a slower clock cycle than some other markets. And I always worry when people say 5G will transform manufacturing as if it's all going to happen next week. And that's just not the case. We were talking to one large industrial company recently, and they were saying that after designing their IoT system, they had to submit it to their IT security guys for vetting before they could connect it to the network. And that security vetting process was going to take 12 months.
Wow.
And I don't know if that's normal, but I do know that there are some quite inherent lags with industrial IoT that make it just a more slow moving market. And I think we just need to be a little careful on our expectations, especially as we all get very excited about 5G and the transformational impact it can have. I think this is going to play out fairly slowly.